as they say, you ask a brick what it wants to be, say an arch. But you ask a mason what he wants to build, and he'll say an arch.
I was really just blown away by how such an old technology was still functioning.
It lasts. We know that. When people talk about a 50-year building, to us, that's really nothing.
There are more than 50 buildings in the Boston area that exist with Guastavino vaulting, but the most significant one by far is the Boston Public Library.
It shows the level of sophistication.
It's an art that goes back beyond my time. I've probably looked at these types of ceilings before and just looked at them.
Many architects and engineers today marvel at the construction of Guastavino vaults, but few really understand how they were put together. We wanted to demonstrate the technology of the vault by recreating a vault.
And what better place than this library, Boston Public Library, right underneath the real thing. And so what we're really doing is just making a half-scale model of what's above. We have to balance all the forces so it doesn't burst, doesn't fall over. This is accomplished by using steel columns, steel ties. The true master builders who built this building didn't have any formwork, any guides for the vaults. We start 4 edges by making arches.
I've worked on many, many arches. Arches, no problem.
From those arches, we start laying tile in a vault shape. So the real magic starts once we start using plaster Paris. The plaster Paris dries fast enough that you can butter up the sides of the tiles, hold it there, and 20, 30 seconds, it'll stay.
And I saw them pulling out a bunch of different tools, just trying to get the geometry right, but it's kind of surprising to know that years prior it was only done by eye and nothing else really.
The first layer is really what makes this Guastavino vault possible.
But rather than close it in the middle, we've left it open and we've peeled back the different layers to try to demonstrate the construction technique made of thin tiles only about 1 inch thick with layers of mortar in between.
It works in like a whole network.
Generally, the last step would be attaching visible tiles on the bottom, and these are usually more ornate.
The bottom right now is the toughest part with the tile from underneath.
Flat tiles in a geometric pattern on a doubly curved surface from below.
I mean, we've just taken this to the PhD level of masonry.
We had carefully drawn 3-dimensional drawings of the vault, but then when you build it in reality, there are always adjustments that had to be made.
Somebody tells you something should be 7 5/8. As an engineer, you take it to the bank, it's going to be 7.625. But as a mason, we know that that's just what it was designed to be, but truly what it is different.
And so we viewed this as a great opportunity to bring together professional masons and craftsmen with architects and engineers and trying to better understand how these are built and trying to create new vaults for the future.
I've always asked the question, why don't you use these anymore?
Just lack of people who know how to do it and lack of awareness.
They should push this type of structure right into the new hotels that they build today. This is a beautiful piece of masonry.
Teaching our young architects and teaching our engineers, and we're desperately trying to get back to masonry.
The Guastavino company was one of the greatest possibilities for creating beautiful, durable structures.
And we are mortals trying to recreate what he did.
That's actually why